Alright, in the last video, we're trying to develop a way of measuring variance, a numerical measure that we could use to describe a data set. And we looked at the possibility of using the average of the distances or differences between each value and the mean. So we were looking at basically these differences here, and we added them all up and we took the average, but we found whenever we do this, the sum of the differences is 0, so it doesn't actually work out. But I said we were close, and actually variance mathematically and statistically is defined very close to what we tried to do here. The only difference is one little number. Let me put it there. So what does that mean? Well, we have the differences, but instead of finding the average of the differences, we're going to find the average of the differences squared. So we're going to find the average of the squares of the differences. So I'm going to take this result here and square it. So I get 625. And you can see by squaring it, I get rid of the negatives, and then when I add them up, I no longer get a 0. Now you might think, well, why can't you just ignore the negatives? I don't know. Okay, I don't know why they didn't define it as just, oh, we'll leave out the negatives. They didn't, though. And I don't have a master's in statistics yet, so I'm not sure exactly developmentally why they decided to just square to get rid of the negatives instead of using an absolute value. But they did. And so our definition of variance, which is symbolized sigma, this is the Greek letter sigma, and sigma squared is called the variance. And it is the average of all these values. So how do we find the average? We add them all up and divide by 6. And that's going to be 875 divided by 3, which is 291.666, so we'll say 7. Okay? And that's how you do it. Let's do it again. Okay? The variance is found by taking the sum of the differences squared and dividing by 6 in this case, because there's 6 elements. So we're going to go, the difference here to the mean is negative 10. Then we have negative 5, 0, 0, 5, and 10. Those are the differences. Those are the x minus mu's. But we need to square those. So we get 100, we get 25, 0, 0, 25, and 100. We add those up, we get 250. Now, we don't want the sum, we want the average of these values, which is why I got the sum. So I could take that sum and divide it by the number of values, the population size. So I'm dividing by 6. 24, 8, 81.7 again, 0.666. So that is the variance for B is 81.7. 81.7. But we don't normally leave it as variance. What we do is we normally take the square root of it, because we define variance as the average of the squares of the differences, and we define the standard deviation as the square root of that. So we square it at some point, we're going to square root at the end, after we get the average, and if what's inside is sigma, then what's inside is sigma squared. When we square root it, we're back down to sigma. So the standard deviation is given the symbols sigma. Sigma for S, standard deviation. Here's a way of remembering it. Mu is Greek letter for M, which is mean. Okay. S in Greek is sigma. S, which is the first letter of standard deviation. Okay. So this is the standard deviation. It's the square root of the variance. Okay, so let's do it one more time. To measure the variability, let me use my highlighter, to measure the variability dispersion within a data set, a measurement called the variance is defined to be, here's the definition of variance, the average of the squares of the distances between each item of data and the mean of the data set. So it's the average of the squares of the distances. It's found using the following procedure, and I'm going to repeat the procedure one more time using the paint cans again from Group A. First thing first, find the mean. We remember the mean is 35. So you find the mean. Now you find the difference between each value and the mean. So you list all the values. Doesn't matter what order you list them in. And you subtract the mean from each one because we're looking for the differences. So when we do that, we get negative 25, positive 25, 15, negative 5, positive 5, and negative 15. And we know if we did it right, those should add up to 0. But we're not going to leave it like that because we want them squared. That's step 3. Square those differences. So we're going to square that. We're going to square that, square that, square that, square that, and square that. Okay. Step 4, find the average of these. How do we find the average? We take the sum and divide it by the number, which is 6. And that's how last time we got the answer. I don't remember. 875 over 3 is 291.7. That's how we got that last time. Now, that result is the variance. So sigma squared is 291.7. If we want the standard deviation, it's the square root of that, whatever that happens to be. The rounding rule is normally whatever these are rounded to, we take it one decimal further for either of these answers. But when you do it in ALEKS, and we're going to do an example from ALEKS now, when you do it from ALEKS, they're going to ask you to round off to more decimal places. The reason for that is, let me round your answer to at least 2 decimal places. The reason is the formulas for population standard deviation and sample standard deviation are very close. And if you don't round it off to 2 decimal places, the computer program can't necessarily tell which which formula you used and whether or not you're using the correct one. So what we're going to do is we're going to find this now. The following data are distances from workplace in miles for 6 employees of a small business. So one person lives 10 miles away, 12 miles, 15, 6, 12, and 11. So the first step is always, if I go back here, is to find the mean. So we're going to find the mean. I'm going to do these calculations in ALEKS so that you'll know how to do it. So in ALEKS, to find the mean, we slide across those and we hit sum and divide that sum by the number in our population, which is 6. So it's going to come out to 11. So once I know it's 11, if my mean is 11, I go mean equals 11. Now I'm going to find the differences between each value and the mean. So I go 10 minus 11. So we have negative 1, 1, 4, negative 5, 1, and 0. And if I did this right, these should all add up to 0, and they do. But I'm not going to leave it there. I'm going to go to step 3, which says square those results. So, and when I add all those up, I get 44. Because I want find their average. So once I square the differences, I'm going to find the average of them by taking the sum of them, which is 44, and dividing by the number of them, which is, again, 6. So 44 divided by 6, 7 and 1/3. So 7.333. Okay? And that is our answer for the variance. So sigma squared is 7.333. But what we're looking for is the standard deviation, so we're going to have to square root that. So it's the square root of 7.333, and I can do that in Alex, and when I do, I get 2.71.